Okay, so I want to demonstrate the difference between an elastic collision and all other collisions. Um, so we'll start with a completely inelastic collision. I'm going to make these two cars collide together. And what you see there is both cars had kinetic energy before they were moving, and now they have none. Clearly, there was a loss of kinetic energy. Where did all that energy go? It went into the cars. It increased their internal energy. And if you listen, you can hear it. Right? That noise is caused by the cars vibrating and sending sound waves through the air that you hear. All right. Now, even if you don't have a perfectly inelastic collision like this one is, and remember, perfectly inelastic is when they stick together. Even if I do a collision that's not totally elastic, even if the cars do bounce off of each other some, there is some lost kinetic energy. Now maybe it's hard to see at the speed I was doing it. Maybe if I push them slower, it'll be easier to see. After the collision, at least one of the cars slows down. All right, there is some lost kinetic energy, and again, you can hear it. So after they hit together, the cars vibrate. Now, let's do a totally elastic collision, which is really a really special case of collisions. Most collisions are not totally elastic, but these cars have strong magnets that repel each other, so they don't actually even touch each other. They repel each other. All right, and if I don't push them too fast, and I don't talk while I'm doing it, you can hear basically nothing. There's a little bit of sound there. So there's no kinetic energy being lost. That's what makes a collision totally elastic. There's no loss of kinetic energy or no gain of internal energy for the cars.